Hello students, welcome to Misostudy and welcome to my class. In my last lecture, I was discussing the problems related to your upcoming JEE Advanced examination. Today I will continue with the same topic and will provide few more information related to that is your coming JEE Advanced. As I told you, JEE Advanced examination is one of the most prestigious examination. Real skill, they check your real skill. If you have the strong command over the theory, then definitely you can solve each and every question. So today I am going to discuss the questions from equilibrium. Basically I will focus on equilibrium. Clear? Yes. Now read the question carefully. What is given? This is a question from titration, that is strong acid versus strong base. Now which type of indicator we are going to use here? Suppose if I write here SCl plus NaOH. Clear to you? Yes. In this case, what we are getting? We are getting NaCl plus H2O. When we take strong acid and strong base, then in this case we know complete neutralization take place. That is complete neutralization take place, and in this case you can use any indicator, that is methyl orange, methyl red and phenolphthalein. This is the case. So for question number 1, 2 and 3 are the correct option. Now the second one is weak acid versus strong base. What? Suppose if I write here CS3COOH plus NaOH. Yes, it is, we know this is the weak acid and this one is, my friend, that is strong base. Now what will happen when weak acid and strong base combine? They form CS3COONA plus H2O. This is a salt of weak acid and strong base, that is the basic salt. That means to say, in this case we need such type of indicator which has high value of pH. Which indicator has high value of pH? That is the phenolphthalein. Clear to you? So for this case, third is the correct option. Am I right? Yes. Now the C, I am moving here, check it out. That is C, the strong acid versus weak base. Suppose if I tell SCl plus NH4OH, it gives NH4Cl plus H2O. This is a salt, it is acidic salt. That means to say definitely we need such type of indicator which works in the low pH range. And low pH range, what we have the option here, that is methyl orange and methyl red. So for C we have the answer, that is 1 and 2 is the correct option. Am I right? Yes sir, you are absolutely right. Now weak acid versus weak base. In this case no such indicator. For example, if I write here CS3COOH plus NH4OH, we will get CS3COONH4 plus H2. Again I am writing CS3COONH4 plus H2O. So in this case no suitable indicator. This is the fourth is the correct option. Clear? Yes, during my lecture I have discussed each and everything and I have taken this topic in my separate chapter, that is volumetric analysis. Clear? Yes. Now I'm going to wrap this part and let's move to the next question. What is the next question? Listen carefully. Now question number 27, again this is a question, multiple choice question. Now this is this question can be done by using a method, that is Le Chatelier principle. Look at here, as I told you in first option given here, N2 plus 3H2, it gives you 2NH3 ammonia. Yes. Now the process is exothermic. What does it mean? For this reaction delta H is equal to negative, and if you want to move the forward side and it is an exothermic reaction, then lowering in temperature, low temperature favor the reaction. So forward shift by lowering the temperature. So for this, S is the correct option. Now check the another one. Now in case of pressure, we know delta N in this case 2 minus 4 minus 2, that is negative. That is, we are moving from higher moles towards lower number of moles. Reactant contains number of gaseous moles 4, but the product contains number of gaseous mole 2. So if delta N negative, that is we are moving towards lower number of moles, then in this case rise in pressure, or you can say increase in pressure favors the forward reaction. So which one? The forward shift by rise in pressure. So for this question we can easily say P and S are the correct option. Clear? Now let's move to the second one. Second one is given 2SO2 plus O2. Is it clear? Yes, it gives you 2SO3. Am I right, my friend? Yes, definitely. Now the reaction is exothermic in nature. That is, for this question, that is delta H is negative. If delta H is negative, then the forward shift is always favored by lowering the temperature. So the first condition in this case, forward shift by lowering the temperature. So S is the correct option. Now check out for the forward shift, what is the delta N in this case? 2 minus 3, that is minus 1. Again we get the value of delta N negative. If the value of delta N negative, that means to say that is rise in pressure favor the forward reaction. So in this case, again what I am telling, that is P and S are the correct option. Now second one is N2 plus, third one is N2 plus, moving here, check it out, N2 plus O2. Is it clear, my friend? Yes, it gives you 2NO. Yeah. This is a endothermic reaction, my friend. For endothermic reaction, we know delta H is equal to positive. So in this case, rise in temperature favor the, again I am repeating, in this case rise in temperature favor the forward reaction. Now look at delta N in this case, 2 minus 2 is equal to 0. So if delta N is equal to 0, that is no impact of pressure. This is the case. Now the D part, what we are getting, that is the PCl3. Look at here, PCl3, yes, plus Cl2 plus Cl2, it gives you PCl5. Again I am repeating, PCl3 plus Cl2, it gives you PCl5. This is endothermic. That means to say, for this case delta H is equal to positive. So if we move in forward direction, that is rise in temperature favor the forward reaction. And now delta N is equal to 1 minus 2, that is 1 minus 2, sorry, pardon. Here we have done some mistake, no? 2 minus 4, that is 1 minus 2 minus 4. Yeah, that is 1 minus 2 and is equal to minus 1. Delta N again negative. So rise in pressure favor the forward reaction. Now moving here, check it out. So in this case, what will you say? That is endothermic reaction, that is rise in temperature, that is forward shift by rise in, R is the correct option, and forward shift P and R, forward shift by rise in pressure. Now next one is unaffected by pressure, Q, and endothermic forward shift by rise in temperature, Q and R and P and R. Clear? Check the things again. Yeah, definitely no effect, that is Q, and endothermic rise in temperature. Okay, these are the questions. Okay, now I am going to rub this part, my friend, and let's move to the next question. The next question we are going to solve here, 28, question number 28. Now what is the question? This is a passage type question. Read the question carefully. in a chemical reaction, the bond of reactant are decomposed and new bonds of product are formed. The amount of energy required to break a particular bond in a gaseous molecule under standard condition homolytically is called the standard bond enthalpy of that bond. Okay, now the next one is bond energies can be used to obtain an approximate value for a reaction. Enthalpy of a gas phase reaction if the appropriate enthalpy of formation are not available. Delta H reaction is equal to bond energy of the bond broken in the reactant minus bond energy of the bond formed in the product. Now let's move to the next. Bond energy depends on, these are the factor. Now the first one, what is given, that is arrange NH, OH and FH bond in decreasing order of bond energy. Okay, the simple concept. If we move towards nitrogen to fluorine, that is if we move along the period, we know due to the increase in the value of effective nuclear charge, size decreases. Clear? That means to say, if I draw the size of this, suppose this is nitrogen and this one is hydrogen. So this is the NH bond. Now second one is, this is the oxygen and hydrogen will have same size in both the cases. This is the OH bond, and again if I move towards fluorine, this is fluorine and this is the hydrogen, again the same size. Now this one. Clear? Now what we find that when we move towards NH bond to FH bond, that is the bond length decreases. What I am telling, the bond length decreases. Okay sir, the bond length decreases. If the bond length decreases, then what will happen? We require more energy to break the bond, that is the bond strength, or you can say the bond energy increases. Am I right? Yes sir, you are absolutely right. The bond energy increases. So what is the order? A is the correct option. FH, OH and NH bond. Clear? Yes sir. Now let's move to the next part of this question. X2 represent halogen molecules. Bond energy of different halogen molecules will lie in the following. As we know, for this question, this is a good question. When we move from fluorine, then chlorine, bromine and iodine, down the group we know size increases. Clear to you? Yes. Yes, size increases. So if I compare F2, Cl2, Br2 and I2. Again I am repeating, if I compare F2, Cl2, Br2 and I2, what do we observe? We observe that the bond length increases. Cl, Br and II. Bond length increases because size increases. So we can say that is down the group bond length increases. Now the thing is, if the bond length increases, then definitely we know bond energy decreases. Yes sir, bond energy decreases. Bond length increases, the bond energy decreases. So what is the correct order in this case? We will write fluorine will have more bond energy than chlorine, than bromine, than iodine. So we got the answer, that is this is the correct option. And what we find, that is A is the correct option. But here you have to check. This is a wrong answer. A is not a correct option, because when I talk about the fluorine, it has 3 lone pair of electron on each fluorine atom. And here due to the smallest size, that is there is a closeness between the lone pair, due to this reason repulsion increases. There is a repulsion, so it will have more bond length, it will require less energy. Better to tell, it will require less energy to break the bond. So in this case, exception, fluorine will have less bond energy than chlorine and bromine. So in this case, what is the actual order? Cl2, then we will write Br2, then F2, then I2. This is the correct order, my friend. Again, I am repeating, Cl2, Br2, F2 and I2. Cl2, Br2, F2 and I2. Now I am going to rub this part and let's move to the next question. Third one, which among the following sequence is correct about the bond energy of single, double and triple? We all know if there is a triple bond, then it requires more energy to break, so it will have more bond energy than carbon-carbon double and carbon-carbon single bond. So this is the case, triple, double and single. So question third part, that will A is the correct option. Now I am going to solve the next question. Now in CH4 molecules, which of the following statement is correct about the CH bond energy? Yes, all CH bond of methane have same energy? No. In case of CH4, look at, this is the bond. Okay, in CH4, what do we observe? We observe that all CH bond of methane not have same energy. Average of all CH bond energies is considered. See the big question, good question. What I am telling, in this case, all average of all CH bond energies is considered. So the fourth part will have answer B. B is the correct option. Clear, my friend? Yes, sir. So this is a passage type question. Now let's move to the next question. Next question is question number 29. Now read the statement. Again, it is a passage type question. Read the question carefully. It is given here, the product of the concentration of the ions. The product of the concentration of the ions of an electrolyte raised to power of their coefficient in the balanced chemical equation in the solution or at any concentration. Its value is not constant and varies with change in concentration. Again, I am repeating, its value is not constant and varies with change in concentration. Ionic product of the saturated solution. Ionic product of the saturated solution is called solubility product. Now, what I am telling, that is, suppose if I take here AB type, then what will happen? It will break like this, A plus into B minus. So KSP will be equal to concentration of A plus and B minus. That is, KSP is equal to S into S. KSP is equal to S square, or S is equal to root under KSP. This is the case. Similarly, if I take the salt of type AB2, it will dissociate like this, A2 plus and 2B minus. Clear? Yes. In this case, what is the format? KSP is equal to A2 plus and B minus square. So what is the value? KSP is equal to S into 2S to the power 2. That is, KSP is equal to 4S cube, and S is equal to KSP upon 4 to the power 1 by 3. Clear? Yes. Now there is a relation. If KIP is equal to KSP, then the solution is just saturated and no precipitation take place. Again, I am repeating, if KIP is equal to KSP, then the solution is just saturated and no precipitation take place. Ionic product given and solubility and the solubility product. If KIP is less than KSP, the solution is unsaturated. Unsaturated means there is a probability, there is a chance to add more solute, and precipitation will not take place. When KIP is greater than KSP, the solution is super saturated and precipitation take place. In two cases, precipitation one case the precipitation will take place, that is in the third, KIP greater than KSP. Now let's move to the towards the question. What is the first question? It is given here, the solubility product of a sprangly soluble salt mx at 25 degrees Celsius. This is the salt ms. It will dissociate like this, m plus and x minus. This is S and this is S, and for this solubility product is equal to m plus into S minus, and the solubility product is given 2.5 into 10 to the power minus 9. The solubility of the salt in mole per liter. We have to find the solubility of the salt, that is S into S. So what we are getting, 2.5 into 10 to the power minus 9 is equal to S square, or S is equal to root under 2.5 into 10 to the power minus 9, or root under 25 into 10 to the power minus 10, that is 5 into 10 to the power minus 5. This is the solubility. So what is the answer? That is D is the correct option. Simple question. D is the correct option. 5 into 10 to the power minus 5. Now my friend, I am going to rub this part and let's move to the next part of this question. What is the next part of the question? Now the second part, that is which of the following is most soluble. It is given here, which of the following is most soluble. As we know, high the value of KSP, higher the value of KSP, higher is the solubility. This is the case, higher is the solubility. Again I am repeating, higher the value of KSP, high is the solubility. Which will have high value of KSP? We find that M and S has high value of KSP, so it is most soluble. This is a simple and plain question, theory based question. Now I am going to rub this part and let's move to the next question. What is the question? Question number 3rd. Read the question carefully. The concentration of Ag plus ion in a given saturated solution of AgCl at 25 degrees Celsius is given 1.06 into 10 to the power minus 5 gram ion per liter. Okay, the solubility product of AgCl. We know AgCl will dissociate like this, Ag plus and Cl minus. KSP is equal to concentration of Ag plus and Cl minus. What is the value of KSP? KSP we have to find, that is Ag plus concentration, and here the concentration of Ag plus will be equal to concentration of Cl, that is equal to S. So we will write KSP is equal to S into S, S square. Now what is solubility? It is in gram per liter, so we have to convert it into mole per liter, that is 1.06 into 10 to the power minus 5 divided by 108. Clear? You will find that is, this is molar, or you can say mole per liter. When given mass is divided by the atomic mass, you will get the mole per liter. Now put this value, that is KSP will be equal to 1.06 into 10 to the power minus 5 upon 108. Put here 100 to the power square to the power 2, that is KSP is equal to almost 1, 10, this will cancel, 10 to the power minus 7. We will write 106 upon 108 multiply 10 to the power minus 7 to the power 2. Clear? Yes. So after solving, what we observe, we will get 106, that is 108 and 106. Okay, 108 into 106 dividing, what we are getting, 10 and 3, not 5 times, yeah, no, what is 6 times, 106 upon 1.06, 1.06 10 to the power minus 5, okay, 10 to the power, this is 100, that is you can write 10 to the power 2, 10 to the power 2, that will come 10 to the power minus 7, okay. 10 to the minus 7, 10 to the power 14, 106, that is around we are getting the answer, no? 106, that is if you solve, then you will get the answer. I do not memorize the answer, so better to put you put the answer. I think calculation is completely correct. It's better to put on here, na, not 108. It is around 107. If I put here 107, that's a better one, because AG has mass between 107 and 108. So calculation will be almost same. That is 1. That is, I think the answer will be 1.12 into 10 to the power minus 10. If you solve this answer, because AG plus has mass ranging between 107 to 108. Clear? Now I'm going to rub. Still, if you have any doubt, format is same. You can calculate. Do not use calculator, my friend. Just use your skill. Just use your calculative power. Now let's move to the next segment. Next question. This is a integer type question. Again, I'm repeating. This is a integer type question. Given here, how much 0.3 molar ammonium hydroxide? Ammonium hydroxide. Yes, sir. That is NH4OH should be mixed to 30 ml of ammonium chloride, NH4Cl. This is a weak base, yes, and this is a salt of weak base and strong acid. This is a salt of weak base and strong acid. That is a buffer solution. Yes, buffer solution. Yes. Now it has value 0.3 molar. That means to say molarity is given how much we require the volume of NH4OH, and the data for NH4Cl, that is volume is 30 ml and molarity is 0.2 molar. Yes, sir. Is it clear? Yes, sir. Completely clear. Now we have to, our target is to find the value of V, and we know this is a buffer solution. Then we have generally 3 type of buffer: acid buffer, basic buffer, and buffer of a single substance. Now the next one is to give a buffer solution of pH 8.65 and 10. That is 2 value. First one pH 8.65 and the second case pH is equal to 10. Now how to find the volume in both the situation? So it's very simple. We know that is pH is equal to 14 minus pKb plus log base upon salt. Am I right? This is the formula we get from Henderson equation. Yes, what is the value of pH? First put here 8.65 is equal to 14 minus pKb is equal to minus 4.75 plus log base upon salt. Is it clear, my friend? Yes, sir. Now solve here. 14 8.65 plus 4.75 minus 14 is equal to log base upon salt. Is it clear? Yes. Now 8.65 plus 4.75 plus 4.75, 5 5 does 10, 7 6 13 and 14, and 8 4 12 and 30. 5 5 10 7 6 13 and 14 8 13. Okay, 14 minus 13.40, that is 0.60 almost value. Yes. So what we are getting, minus 0.60 is equal to log base upon salt. Log base upon salt. Now what will happen? Take anti-log. Take anti-log. We will get base upon salt is equal to anti-log minus 0.60. It will have value around 0.25. Clear to you? It will have value around 0.25. So what we have, base upon salt. What is the base? Base is this one, 0.3 into V divided by 1000. What is the salt? That is 30 into 0.2 divided by 1000 is equal to 0.5, can be written like this, 1.4. This will cancel this one. Now what to do? That is 0.3 into V upon 30 into 0.2. This will cancel this one, that is 10. That is 1 by 4. So we will find it out, that is 4V. Let me check the things once. Don't be in a hurry. That is 2, 10 to, yeah. V upon 20 is equal to 1 upon 4. So 5, that is V is equal to 5 liter. Clear? First we are getting, when we take pH is equal to 8.65, we get the value V is equal to 5 liter. Now the second part, pH is equal to 10. Again put the value 14 minus pKb plus log base upon salt. Put the value. Yes, 10 equal to 14 minus 4.75 plus log base upon salt. Am I right, my friend? Yes, sir, you are absolutely right here. Yes. So put here 10 plus 4.75 minus 14 is equal to log B upon S, base upon salt. So what will happen? 14.75 minus 14, that is 0.75 is equal to log B upon S. So take the value B upon S is equal to anti log 0.75. Put the value here. B is equal to, similarly we will write 0.3 into V divided by 1000, because this is in ml, convert it into liter. 30 into 0.2 divided by 1000 and equal to, my friend, anti-log 0.75. Can you solve this question? Yes, sir. Now you can easily solve this question. I'm moving here. Check it out. So these are the simple questions, and definitely this question, my friend, will help you a lot while solving the question related to chemical and ionic equilibrium. Am I right? Yes, sir. You are absolutely right here. Now let's move to the next question. What is the next question? Question number 31. Question number 31 is given. What is the minimum volume? What is the minimum volume required to dissolve 1 gram of calcium sulfate? Again I am repeating, what is the minimum volume required to dissolve 1 gram of calcium sulfate, calcium sulfate at 298 Kelvin, KSP value. Now this is calcium sulfate. It will break like this, Ca2 plus and SO4 2 minus. Now KSP will be equal to, we will write S into S, S square. KSP is equal to 9.1 into 10 to the power minus S root under. Okay, we will get the value around 3 into 10 to the power minus 3. Is it? This is the value of S. Lump sum figure? Yes. Now they are asking minimum volume water required 1 gram. Now we have to convert it. This is in molar, mole per liter. Now we have to convert into gram per liter. Now what is the mass of CaSO4? The molecular mass of CaSO4 is 40 plus 32 plus 64. Am I right? Yes, sir. Check the thing. 40 plus 32 plus 64, that is 72 and 64, 4 to 6, 7, 6, 13. That is the value is 136. So the solubility is 3 into 10 to the power minus 3 multiplied by 136 gram per liter. Clear? Yes. Now it is very simple. That is 136 into 3. 136 into 3 multiplied 10 to the power minus 3 gram is present in 1 liter, and you have 1 gram. So 1 gram will present it 1 into 1 divided by 136 into 3 into 10 to the power 3 minus 3. That will be equal to 10 to the power 3 divided by 136 into 3. If you solve this one, you can get the answer easily. So these are the questions, are very simple. Command over the theory will help you a lot to solve such kind of questions. Again I am repeating, practice, practice, practice makes a person completely perfect. So do practice lots of time. Clear? Now friend, time has come, time to say bye bye. Thank you so much.